chapter 2, and we're going to look at number 6, and this is on page 59. Yeah, 59. It's on page 59. Okay, so we have a Honda Civic travels in a straight line along a road, and the car's distance x from a stop sign is given as a function of time by the equation. All right, so that's first thing we're going to do. Notice they give you the equation, and the equation is x with respect to time is equal to alpha t squared minus bt cubed, and they give you where a is 1.5 meters per second squared and beta, is 0.0500 meters per second cubed. Question 6 on chapter 2.
You got to scroll down. That's what I was trying to do. The things. I was doing exercises. Yeah, there's like.
I'm sorry. Did I say problems? I meant exercises. Yeah, exercises. Did I not put that in there on when I sent the exercises? Yeah.
It doesn't really say clearly, like when you're looking at it, it just says like 1, and then you scroll down and again.
Okay. But I did put exercises in the email, didn't I? Okay. Yeah, and y'all are looking at it in the ebook, right? Yeah, I forget about that. Yeah. I forget about it. I know what you're talking about, it doing that to you. Yeah, I'm sorry. Okay. Yeah, it's always going to be exercises. We will do some problems later on, but I should have denoted that in the email where there's a few problems we'll actually do. It says problems later on towards the end of the problem section, exercise. Okay, thanks for bringing that to my attention. Yeah, so we're on exercise 6, page 59. So what do you do first? How do you solve these problems? Well, first thing you do is you draw it, and it doesn't have to be perfect, so we're going to draw a car here. You draw it, and here's our stop sign. We'll just pretend it's down here. Okay. And so we draw it, and then we write our equation. We write what we know. You always do the known first. Now, this should be old hat, y'all. Y'all have done a lot of math. You always put down what you know first and label it and draw it, and then look for the unknown. Okay. So what was our equation? Our equation with x with respect to time is equal to, and it was alpha t squared minus beta t cubed. So it's alpha t squared minus beta t cubed, right? Okay. And then it gives us the values for alpha and beta. Well, you always write those down. So the values for alpha is going to be what? The values for alpha is 1.5 meters per second squared. So it's 1.50, and that's important because that's 3 significant figures. Meters per second squared, and beta is going to be what? 0.0500 meters per second cubed. Now, I know you're thinking, what is meters per second cubed, guys? You got to remember derivatives. Okay. All right. And that's supposed to be beta. I didn't make my beta too hot there. Okay. So we've drawn it, and we are to assume it's moving. It's a straight line, and when it says that, we're assuming it's moving in the x direction. Okay. Notice what it says. It says, calculate the average velocity of the car at these time intervals. So for A, it's time interval 0 and time interval 2 seconds, okay? So for 6A, we're going to look at the average velocity, right? So calculate the average velocity. So the velocity average at time is equal to 0 seconds and time is equal to 2 point, and I think is it 2 zeros, 200? 2 point, well, shoot. 2.00. Yeah, thank you, because that's 3 significant figures. Okay, in other words, it goes to the nearest hundredth. Okay, guys, so notice what we have here. We have our function, our equation. We have our values of alpha and beta, which are constants. We know the time interval that we're looking at. But we've got to find the velocity average, right? That's the question mark, okay? Well, we're given an equation for x, and by definition, how do we find, and notice it didn't say instantaneous velocity, it said average. By definition of average velocity, velocity average is what equation? It's Yeah, or x2. Now remember, we're talking about linear, all right? We're just talking about, remember, chapter 2, one dimension, all right? Delta x over delta t, right? Now, how'd you know to do that, Mr. Shields? Well, guys, look, because it said velocity average. And what is the formula for velocity average? Well, it's the change in displacement divided by the change in time. Notice I said displacement. Okay? All right. Well, Miss Shields, we've got a problem. We don't have x, do we? We have time. We've got the time interval. But we don't have x, do we? Well, not directly we don't. I mean, it's not saying x is 5 meters and x1 is 5 meters and x2 or x final is 10 meters. It doesn't directly say that. But guys, look, you have a function and notice it's x. So can I find x if I know my time interval? Yes, you can. So what do? Well, you just plug it in. Times 0 is equal to, all right, alpha was what? 1.50 meters per second squared times 0 seconds minus, I don't really need to write it, but I'm going to. Just keep everybody happy. 3 significant figures, meters per second cubed times 0 seconds. Well, guess what you get for meters? You get 0 meters. Now, y'all, this is going to be on video, by the way. I might have to edit that first part out, but anyway, it's not a big deal if I don't. Okay? Now, that's at time 0. So how do I find it, the displacement for 2 seconds? Plug it back in, right, for 2 seconds. Yeah, and notice how I'm writing it right here. Notice that. Now, y'all, I left off the 0.00, but we know it's 3 sig figs, just for brevity's sake, okay, not to take up, too much room. All right. And I do that a lot. So we say 1.50 meters per second squared times 2 seconds, and that's 2. And again, we know it's 3 sig figs. We know that, and there's 3 sig figs there. All right. Minus, all right, 0.0500 meters per second cubed times 2.00 seconds. I'll go ahead and put it in here. Is equal to, and we should get what? What is it? 5.6? Or no, yeah. We should get 5.6 meters. Did everybody get that? And by the way, it should be how many significant figures? 3. So it'll be 5.00, right? Because there's 3 sig figs, 3 sig figs, 3 sig figs, 3 sig figs. Is that right? Did everybody get 5.6? Did what now? Okay. Did I do something wrong? Oh, wait a minute. I left something off, didn't I? I forgot to square it here, and I forgot to cube it there. Thank you. Thank you. I forgot my square and my cube. Now, it should be 5.6, because 2 squared is 4, and 4 times 1.5 is what? 6? Okay. And 3 cubed, 2 cubed is what? 8. And what is 8 times 0.05? 0.4. So 6 minus 0.4 is 5.6. Okay. And that's fine. Please question me. That's fine. I forgot my squares and my cubes. Sorry about that. I'm getting in a little bit of a hurry. I got to slow down. Okay. Thank you for calling that to my attention. All right. Okay, so now we know our displacement, don't we? Now what do I do? What equation do I use? Hello? We need average velocity. Which equation gives you average velocity? See, this is why you don't just start taking numbers and sticking them in somewhere. You got to write everything down, look at it, and say, oh, yeah, I don't really know my x, but I got a function for x. So I use what? Do I use that average velocity equation? Well, is that what I'm looking for? Okay, use it. So velocity average. Look, guys, how'd you know? Well, how do you know that, Mr. Shields? Well, look, guys, this is final velocity, and that's initial. Well, how'd you know it's final and initial? Well, initially you started time 0, and then it went to 2 seconds. That has to be the final time. Okay. And I'm not aggravated at you. I just put inflection in my voice, so I'm not talking monotone and drive you insane. Okay. We don't want to be monotone, do we? So it's 5.6 meters, and what's the time interval? It's 2 minus 0 seconds, which is 2 seconds, and so we get an average speed of what? 2.8 meters per second, and that should be 2.80, right? Because it's 3 significant figures, so we should write it as 2.80 meters per second. Everybody concur? Does that make sense? Does that make physical sense? Well, it should. Okay. All right. Any questions? All right. Now let's look at part B. So 6B, we do what? Well, guys, we're doing basically the same thing. We're just kind of doing the same. We got time interval 0 to what? 4 seconds. So at time, we're looking at the average speed at time 0 seconds to time 4. Is that right? 4.00. Thank you for confirming. Okay. Well, guys, what do? Same thing. We say x is 0. Look, guys, do I need to fill all that in? 1.50 meters per second squared times 0 seconds squared minus 0.0500 meters per second cubed times 0 seconds cubed is 0. Come on, guys. I mean, I really don't even have to plug that in, but, just want to keep everybody honest, right? And then that would be the same thing as saying initial or time 1 or not. Okay? If I said x naught or not or whatever, okay, that's same as initial, that's same as 0, that's same as 1. Okay. And then x at time 4 seconds, and that's 0 seconds, 3 sig figs. So you say 1.50 meters per second squared times 4 seconds squared minus 0.0500 meters per second cubed times 4.00 seconds cubed is equal to I can't read my own handwriting. Is it 20.8 meters? 20.8 meters, and that's 3 significant figures. 20.8 meters. Okay, so we have our time interval, we have delta t, we have our delta x. So its velocity average is equal to 20.8 meters divided by, what do we have? 4 minus 0, which is 4, and you get an average speed of 5.2 meters per second. Is that right? 5.20 meters per second. Is that right? Okay. Any questions on that? All right, and then how do we do 6C? Well, guys, same way. Same thing. So we have the average velocity average at time intervals of what? 2 and 4, is that right? Yeah. Now notice we didn't start at 0 there. Well, it's still initial because that's where you start. So it's what? Time 2.00 seconds to time 4.00 seconds. So we do the same thing. Now here, y'all, I'll have to plug in and calculate for the initial, right? Because it's at 2 seconds. It's not 0. So we'll have to calculate. So we put 2 seconds, right? And then we come in and do what? We say 1.50 meters per second squared times 2.00 seconds squared minus 0.0500 meters per second cubed times 2.00 seconds cubed is equal to, and what do we get? How many meters is that? Oh, shoot. Next page. How much? 5.6? Yeah, thank you. 5.60 meters, 3 sig figs. All right. So that's the initial. We can call that I, or initial. And then the final is going to be x at time interval 4.00 seconds, which is going to be equal to, we got 1.50 meters per second squared times 4.00 seconds squared minus 0.0500 meters per second cubed times, flip, 4.00 seconds cubed. And we get what? 20.8? Yeah, 20.8 meters. All right. Now we come in here and say velocity average is equal to, well, delta is going to be 20.8 meters minus 5.600, 10 meters divided by 4, I'm just going to say 4 minus 2, we know it's 3 sig figs, seconds, and we should get an answer of 7.6. Very good. 7.60. Very good. That's exactly right. Meters per second. All right. Good. Boomo. Are you good with that? Okay. See, that's not bad. That's not too bad. But again, guys, you just got to, what do you do first? The first thing you always do. Now, I know I didn't write this out, but come on, guys. Y'all can listen and write this down. You know, this is not first grade. Okay. Thank God for first grade, but we're not in first grade. Draw and label everything. Write down your knowns, what you are given in the problem, and then write your unknown that you're looking for that you don't know and put a question mark by it. Then you start looking at equations. Okay? And you don't automatically just pick one and start stuffing stuff in it. You have to look at your knowns. Your knowns will tell you what equation you need most of the time. Okay. All right, you want to do another one? Or are y'all done sick of me? All right. No comment, please. Okay. One down, yeah. See, it took a little time, didn't it? It just does, guys. Now you see why I'm on an exam, I can't give you. Usually I try not to give you more than 2 parts on a problem. And I don't give you 2 parts on every problem. But I do try to make the one-parters challenging some. You know, every now and then there might be one problem that has 3 parts. But usually it's the third part simple. It's like, how do you know the acceleration, it's got constant acceleration or something? And that's not math. You just look at it and tell me. You'll see what I'm talking about. All right. All right, you want to do number 8? And the reason I'm picking these even numbers because those answers are not in the back of the text. Well, gee, thanks. Okay. Well, I'm trying to help you. All right, let's look at number 8. You want to do that one? That one's a little bit involved, but that's a good problem. Do what now? Yes, they're being recorded. Yes, right now. I may have to edit a couple of things there at the beginning where we kind of, you know, but maybe not. Okay, yeah, it'll be on video. Yeah, lecture video, probably video. Yeah, it'll be right there. I'll have it labeled. Okay. All right, everybody want to look at number 8? I guess so. Nobody's saying anything. All right. So chapter 2, number 8. All right, well, let's read it. Okay. And it says, a bird is flying due east. Its distance from a tall building is given by, and it gives you the x, right? It gives you x. Tall building given by x, t is equal to 28 meters plus 12.4 meters per second, t minus 0.045 meters per second cubed, t cubed. What is its instantaneous velocity of the bird at 8 seconds? Okay, at 8 seconds. Okay. Okay. All right, so first thing we're going to do is do what? We're going to cry. No, we're not going to cry. We never cry. It's no good. So we want to draw the bird, right? And so we got a bird flying. See if I can draw a bird. And there's his wing, and there's his beak. Okay. All right. Yeah, I know. All right. So he's flying due east. That's east. Remember I said you draw it and label it. Okay. And then we write the function, right? And it's x with respect to t. So we say x with respect to t, which is time, is equal to 28.0 meters. 28.0 meters plus 12.4 meters per second plus, and it's in parentheses, 12.4 meters per second t, right? Minus 0.0450. Minus 0.0450, and that's meters per second cubed, t cubed, right? Meters per second cubed, t cubed, right? So they gave us this function, and it's x with respect, and we want to know what is the velocity instantaneous, and as the limit approaches what? 8 seconds, right? As it's approaching at 8 seconds. Okay. So we want to know the instantaneous velocity. Well, okay, guys. Do we have, now look at our function. That is x. But we're looking for what? We're looking for velocity, right? So we've got to do what? Take the derivative. Well, how'd you know? Well, look, it's asking for instantaneous velocity, question mark. I don't have a function for velocity yet. So we take the derivative. Well, we know that dx over dt, remember, remember dx over dt is what? It's v. Okay? So the velocity equation with respect to time is going to be equal to what? Well, what happens to 28?
0.
It's 0. Well, why? Well, because there's no t on it. You take the derivative of a constant, and it goes to 0, right? All right. See, don't forget your calculus now. All right, 0, and you said it. You didn't forget it. And what happens to 12.4? It's 12.4t, so the derivative of t is what? 1, right, basically. So it stays 12.4, doesn't it? So, 12.4 meters per second, right? And then it's minus, well, what do I do with my 3? I got to multiply it times whatever's in the brackets, in the parentheses, excuse me. And that number, let me just go ahead and do it. Let me just go ahead and carry it out. 3 times 0.0450, right, meters per second. Now, look, you don't change the units. Don't mess with those units. It's still meters per second cubed. And that becomes what? T squared. Okay, so let's finish this out now. The velocity with respect to time is equal to, let me go ahead and carry this on out. 12, dad blast it. I'm getting in a hurry. My bad. It's 12, crazy head. All right, 12. Do what?
You're excited about physics.
Yeah, I'm just all caught up in physics land. I'm telling you, 12.4 meters per second. All right, and 3 times that is what?
0.135.
0.135 meters per second cubed. And that's what? T squared? Now let's plug in the time. 8 seconds, that's 8.00. 12.4 meters per second minus 0.135, 3 sig figs, meters per second cubed, times 8.00 seconds squared. When you square seconds, what happens? Seconds squared cancels out the cube and leaves you with what? Meters per second, which you are supposed to have. You see why it's so important to keep everything dimensionally correct. Don't mess with those units. Okay, I know I'm like a mother or a father, but okay, so the velocity, and by the way, this is at, and we want to write it at 8 seconds, is what? 3.76 meters per second, right? And again, 3 sig figs. And you do need to pay attention to that, because I'm going to tell you, engineering professors are really they're going to howl on that, all right? So 3.76 meters per second. Now, let me ask you this question, and I will on the exam. This is one of these 2-part questions I would ask you, like, okay, guys, is the acceleration here constant? Do we have constant acceleration with this particular problem? How can I find that out?
You have to, if you put in a different amount of time, do like 3 seconds or something like that, and see if it was the same.
Okay. All right, look at our function. First order derivative from displacement is velocity. What's the second order derivative? Acceleration. Okay. Take another derivative from that same equation right here, from this equation. What do you have left? It would be 6, and it would be what? 6 times 0.40450 meters per second cubed, and what would happen to t? Just be t. But it would be a with respect to time is equal to all that. Okay. So do we have constant acceleration? No. Why? Okay, because t is still in the equation, right? If I took it, let's go ahead and do that. If I did go ahead and do that next derivative, a with respect to time, it'd be equal to what? 6 times 0.0450 meters per second cubed t. That tells me it's not constant. It's dependent on time. Now, you were talking about doing time. It is time dependent, but how do we know it's time dependent? You have to go ahead and take that next derivative. If we had taken that next derivative and there was no t, then we would say it's what? Constant. Hello, hint, hint, hint. You know what I mean by hint, hint, okay? All right. All right. Any other questions? Yeah, that means it could be on the exam. That's code for could be on the exam. Of course, there's a lot of things that could be on the exam. Okay, y'all satisfied? Y'all don't want to do any more problems? Don't look like it. Okay, we'll stop there.